What's up, people? Welcome to the session. How are you guys doing? Welcome. My name is Anoop, and this is the VIP series where we will be solving some very important questions from the chapter electricity. That in particular, we'll be talking about the heating effect of electric current. We'll be solving some very important questions, very super awesome, like think questions that could actually appear in your boards, and more importantly, that's going to help you think a little. That is the type of question that we're going to go for. So welcome to the session, and yes, I hope that your preparations are going good. And if you guys ever feel a little stressed out, I would tell you guys to take a break. Take 1 hour, 2 hour break. Stop thinking about anything. Stop worrying about everything for a second there, and just chill out and then get started. All right. Do not overwork yourself, but at the same time, don't just give up as well. All right. So good luck for your exams, guys. With that said, let's begin the heating effect of electric current. Before we get started, guys, this was the question that I asked you in the last session. So the question was: a 9 ohm resistance is cut into 3 equal parts, and are they connected in parallel? What would be the equivalent resistance? So basically, guys, if you divide a 9 ohm resistors equally into 3 equal halves, that'll be what? It'll be 3 ohms each, right? So this will be 3 ohms, 3 ohms, and 3 ohms. So if you connect them in parallel, what is it going to be? So it's going to be 3 by 3, which is nothing but 1. So your equivalent resistance would be 1. That's all. That was the question. It was quite simple, super easy. But today's questions are going to be a little bit more on the higher order side. But the first couple of questions are going to be pretty easy. And then we'll start to get into the main stuff, which will help you guys, use that Sherlocky brain of yours. Alright, so here is your first question, guys. It's a sample paper question. It's quite a simple one. The question is this: if the current flowing through a fixed resistor is halved, the heat produced in it will become what? Doubled, half of it, 1/4, or 4 times? Quite simple. Let's try and do this. Now, I want you guys to remember two important formulas. One is basically the formula of power. Power is nothing but what? Voltage into current. And heat, heat energy is what? It's nothing but VIT, which can also be written as V square by R into T, or it can also be written as I square RT. So these are the three formulas that I want you guys to remember. Now, how did I come to derive these formulas? Remember Ohm's law. So in place of I, you can substitute once, or in place of V, you can substitute once, and you'll get the. So depending on the question, you can choose any of these three formulas. All right, now. Here they're talking of the current. So I'm going to use the third formula over here, that is I square RT. If the current is halved, what would be the heat produced then? So it will be what? I square, so square, whole square divided by R into T. So it'll be 1/4 I square RT is what is going to happen. So what happens to the heat energy then? If the current is halved, then the heat energy produced would be 1/4 of the original heat energy. So the answer to that question is option number 3. Right? Simple. All you have to do is substitute the values. All you need to do is remember these formulas. That's very important. Once you remember the formulas, everything will just fall into its place. Alright. So that is the answer for the first question, guys. Moving on to the second one. Here's another one. This is a logical thinking. You don't need to use any formulas and stuff, but you need to understand about some of the factors that affects resistance and heat production or heat energy produced in a circuit. So here's the question. The amount of heat produced in 10 minutes in a given circuit is more in a thick copper wire than a thin copper wire of the same length, less in a thick copper wire than a thin copper wire of the same length, can either be more or less depending on the room temperature, or none of these. Easy question, guys. You just need to understand the factors, right? Remember, see guys, why is heat produced in a circuit? Heat is produced because of resistance. Now, if that is the case, then which of these options do you think would be correct? Resistance is indirectly proportional to thickness. If the thickness is more, then the resistance is going to be less. If the thickness is less, then the resistance is going to be more. Now, among the first two options, the first one says that the first one is thicker, and they are saying that the heat energy produced on the wire which is thicker is going to be more than the wire which is thin, which is obviously not true. Second one, however, says that it is less in the thicker wire but more in the thinner wire, and that should definitely be the right answer, because see, it's indirectly proportional, because again, heat energy is produced because of the resistance. So what are the factors that I know that resistance depends on? One of them is thickness. So because the thickness is less, there'll be more resistance and hence more heat energy. That's it. That is another answer. Very, very simple. Taken from sample paper, guys. So, quite an easy one. All right, third question. This appeared in your 2011 board exam. This is going to be a little bit more, not complicated, but you'll have to do a little bit more calculation than this to really understand this question. Two identical immersion heaters. You know those water heaters that comes out like a rod and you dip it in the water. That's what it is. All right. They are used to heat up the water in a large container. Which one of the following arrangements would heat the water faster? That's the question here, alright? The first one, connecting the heaters in series with the main supply, or the second one, connecting the heaters in parallel with the main supply, or either of these, or can't say. Let's try to do it, alright? Let's try to do it. Now, there's no space, so I'm going to do it over here. It's a place. Now remember guys, heat energy produces what? It's nothing but I square RT. Or you can also write it as V square by R into T. Now, power is what? Power is equal to V square by R. This is one of the formulas. V into I, in place of I, if I substitute V by R, you'll get as V square by R. Alright. Now, power, that is nothing but you can call it as heat energy. So we'll take it as V square by R into T itself. Alright. We'll just take the first formula itself. Now, when it's connected in series, what will be the resistance? It will be R. S will be R1 plus, or we'll take it as R. R plus R is equal to 2R. Alright. So let's say that both of them are the same resistors. Alright. Resistance is also the same. Alright. Now in the second one, when they're connected in parallel, it will be 1 by R plus 1 by R, which is nothing but 2 by R. So this is 1 by RP, sorry. So what will be RP? RP is equal to R by 2. Now substitute this value in this equation. Let's take T as 1 second. Alright. Let's take T as 1 second. So for the first one, H1 is equal to V square divided by 2R is what you're going to get. So what is the heat energy produced? That's 1 by half. So it will be 1 by 2. Now 1 by 2 V square by R is what you can get. For the second one, however, what will be? It will be 2 V square divided by R, because R is R by 2, RP is R by 2. So take 2 to the numerator. So it will be 2 into V square by R. So what will be? It will be 4 into V square by R. So what are you going to get? You'll get it as what? You'll get it as 4 times. So basically guys, if you connect it in parallel, then the heat energy produced would be more. So the right answer would be option number B. That's all guys. So you just need to remember the formula, substitute the values, and do a little bit of jugaad here and there, and you'll get the answer. It's just that, I took it a little longer to do this. It's actually not this long. If you practice a lot, it'll be a lot more easier. In order for you to understand it better, that's why I had to do it this way. And yes, I did not have any space to write as well. So that's why it's all really clumsy. But I hope you get the point, people. I hope you're able to understand the question, right? So that's how you do it. Moving on, people. Moving on to the next question. So that's how you do it. So the answer to this question is that when you're connected in parallel, that's when. So in series, as you guys already know, the resistance is already too much. So because of the resistance, there'll not enough heat energy will be produced. In other words, there'll be not, the flow of current would also be less. So they'll not be able to heat up the water as much. But when you connect it in parallel, because the resistance is less, you'll be able to heat up the water much more, because more amount of current is passing through it. So that's the answer. All right. Moving on, people. The fourth question taken from 2010 board exam. It's a very simple one. Trust me, it's like two-step answer. This one is, how much heat will an instrument of 12 volts produced, 12 watts, sorry, 12 watt produce in 1 minute if it's connected to a battery of 12 volts? Option 680 joules, 12 joules, 720 joules, or 120 joules. So you're supposed to find out what is the heat energy. So heat is nothing but power into time. Because again, power is what? V into I. So if the formula is P, H is equal to V into I into T. So instead of VI, I'll put it as P because it's the same. So what is P? P is nothing but 12. Time taken is 1 minute. That's nothing but 60 seconds. So 12, 1, 6, 1, 7. So 720 joules would be the answer. Again, two-step, people, two-step. And I hope you guys are able to give the right answer for this one. This is like probably one of the most easiest and straightforward questions that they're ever going to ask you. So again, this appeared in your 2010 board exams. So keep an eye out for this one, alright? So the answer is 720 joules. Moving on, people, another question taken from sample paper. This is also quite a simple one. You'll have to do a little bit of calculation in jugaad, but it's quite an easy one. The question is this. An electric heater having resistance equal to 5 ohms is connected to an electric source. If it produces 180 joules of heat in 1 second, find the potential difference across the electric heater. So let's try to write on the value. First of all, let me just see if I can. So there's space. So yeah, guys, resistance is given as 5 ohms. The heat energy produces 180 joules. The time taken is given as 1 second. So again, h is equal to I square. We'll take it as okay. We'll take it as v square RT because we're supposed to find out what is the potential difference. So v square by r by t. So 180 is equal to v square by r is 5 into time is 1. So 5 goes to the other side. So 180 into 5 is equal to v square. So that's I believe it's 900 is equal to v square. So v is equal to root of 900, which is nothing but 30 volts. That's the answer, people. I'm pretty sure that is the answer. Yes, it is. So 30 volts will be the answer to this question. Again, direct substitution and getting the answer. That's all. There's nothing too complicated about it at all. Substitute, find the answer, move on. That's all. Moving on to the sixth question, people. Take it from sample paper again. This is quite an interesting one. The question is this. We have two resistors R1 and R2 having resistance values of 5 ohms and 10 ohms respectively. Find the ratio of heat produced in R1 and R2 in 5 minutes when they are joined in series across a battery of 5 volts. Options 1 is to 1 is to 2, 2 is to 1, 1 is to 4, or 4 is to 1. This is an amazing question. Let's try to solve this. Alright, this is going to take a little longer, so have some patience and try to do it with me. I want you guys to try out this question. Alright. So first of all, guys, find out it's connected in series. Alright. So find out the current first. So current is equal to what? V by R. V is given as what? 5 volts, and the resistance is what? It's connected in series, so 5 plus 10, it'll be 15, right? So 5, 3, 15, so it's nothing but 1 by 3, which I can write it as 0.33 amperes is the current that is drawn. Now, the question is, find the ratio of the heat produced. So put it on, so H1 is equal to I square RT. So I square is 0.33 square into R is nothing but 5 into time taken as, we'll take it as 5 minutes, right? 5 into, convert that to seconds, so 5 into 6 is 30, so 300 seconds. So if you calculate the 0.33 into 0.33 into 5 into 300, you'll get as 163.35. Something around this is what you get. For H2, again, find out, substitute the value for R over here. So I square is 0.33 again, 0.33 the whole square into 10 into 300. So what are you gonna get? So if you'll get it as, if you multiply this, you'll get as 326.5. Something around this is what you get. Now find out the ratio H1 by H2. If we divide 163.35 divided by 326.5, you'll get as 1. Basically, you'll get it as 1 by 1.99, something like that. So you can take it as 1 by 2. So the answer to this question, guys, will be 1:2. Now the ratio, again, you'll get it close to 2. That's why I'm taking it as 2. You'll get it as 1.9, something like that, 1.92, 1.91, something around that way. That is what you're gonna get. So you can just write it as 1:2. So that is the answer for this question. That's all, guys. That's it. Simple. Again, this was probably one of the longest question involving a lot of calculations, but again, quite a simple one, direct substitution. You just have to calculate the values, and in your exams, try not to get the calculations wrong. That's all. Alright, that's all I can say. Alright, people. So yes, if you're enjoying this session so far, do not forget to hit the like button. Do not forget to subscribe to the channel. And also, guys, if you want to learn these kind of topics in detail with the best of the best teachers, click on the link and enroll into the Vedantu Pro course right now. First of all, guys, you have unlimited live session. You have unlimited number of live sessions going on every single day. Sessions are going on 24/7. Whenever you feel like studying, you can log into the website or into the app and study from your favorite teachers. And all of those sessions will have amazing quiz questions, and you'll have a lot of fun as well because you get to interact with your teacher, with your friends. So it's going to be like a lively classroom. And these quizzes will also give you an opportunity to compete with the rest of the world and see what are your strengths as well as your weaknesses. So you can see what are the topics that you're feeling a little hard, and you can also understand what are your weaknesses, so you can work on those topics and be better before your board exams are here, right? And yes, all the sessions are recorded, and the recordings are such a way that even while watching the recordings, you can take the quizzes and check out the leaderboard. Like, How amazing is that? Like, it's like mind blowing. I wish I had all of this when I was in my school. But nonetheless, you guys have the opportunity to avail all of that, guys. So interactive replays while watching the session, while watching the replay, you can take the quizzes and check out the leaderboards. And yes, we know that notes are important. Do not worry, people. All the notes, all the premium content, everything is downloadable, so you can refer to it whenever you want, wherever you are. It does not matter. You can download it and go through all those notes at any point of time. With all of these, guys, this, trust me, is the thing that is going to blow your mind off. Every session will not just have one teacher. No, no, no. With the master teacher, you will also have the class teacher to help you clear every single doubt of yours. Live doubt solving, unlimited live doubt solving, right there and then inside the session itself. No matter how many doubts you have, 50, 100, 200, 250, does not matter. All of your doubts will be cleared right there and then, because I know for a fact that right now, since you guys are preparing for your exams, you have a lot of doubts in your mind, and getting your doubts cleared is the biggest problem right now, since you don't even have school to go to. But don't worry, guys, we've got you covered. All of your doubts can be cleared right there and then. And yes, 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 you also have tests and assignments as well, which will definitely help you to understand what type of questions you can expect from your board exams, and work on those kind of questions as well. So it's a one-stop shop for everything that is related to your educational needs. So what are you supposed to do? You must be wondering that. All you have to do is this, guys. So first of all, go to our Vedantu 9th and 10th English channel, subscribe to the channel and hit the like button since you're watching the video already. So open any of the videos. So I think this is one of the videos that is going on right now. So I'm just gonna pause that right there. So guys, go to subscribe to Vedantu Pro right now. You can also check out all the playlist of 9th standard, 10th standard. Everything would be there in the description itself. Any topics that you are feeling is a little hard, you're not able to understand it, you can go through those videos that is given in the links and check it out for yourself. And whatever doubts you have, you can shoot it to us as well. So yes, guys, click on this link and it will directly take you to this page. Now if you are someone who is currently in 10th standard, what you have to do is click on CBSE 2021. So once you click on it, guys, you can check out all the details over here, revision of all the subjects, math, physics, chemistry, bioscience, all of your science, SST, English, everything is covered over here. If you go for the 1 month program, guys, which I would suggest you to do that. So if you go for the 1 month program, the base price of that is 1,500 rupees, which is very, very affordable, and it's for your own future, to make sure that you're able to understand the concepts and get better. Now if you click on proceed to pay, you get a discount on that and the price drops down to 1,200 rupees. You can use any of these, Paytm, phone pay, any of these things can be used to pay. Now if you're someone who is in 9th standard moving to 10th standard, then you have to go to CBSE 2022. Here you can check out all the schedule, all of the teachers that will be teaching you, all of the topics that will be covered. Everything can be seen over here. Now if you go for the 1 month program over here, it's 3,300 rupees, but again you get a discount on that, so don't worry about it. So if you click on it, guys, you get a flat 6,660 rupees discount, and the price drops down to 2,640 rupees, which again is an affordable price. Now if you go for the whole year program, that's 38,880 rupees. But again, once you click on proceed to pay, the discount is automatically added. You get a flat 7,776 rupees discount, and the price drops down to 31,104 rupees. Yes, people, that's how much you'll be paying for the whole year till 2022 March. Everything, revision, your regular sessions, quizzes, the best of the best teachers, with more than 2,000 plus micro courses, everything available to you at your fingertips. Now if you think about the value of money, you must be still wondering, sir, what about the value of money then? If you go to the 1 month program, people, and like I told you, you'll be paying about 1,200 rupees. You don't have to go till June. It's not needed. If you go for the 1 month program, that means that in this 1 month duration, you've attended at least 200 sessions, right? Which means that per session, you're just paying 6 rupees, which is less than a packet release. Now, if you go for the 2022 session, that is people who are moving from ninth to 10th, the base price of that you'll be paying up, after the coupon code is 2640. Now in this 1 month duration, you've attended 200 sessions again, which means that per session you're paying 13.2 rupees. Now if you go for the year-long program, it's going to be even more lesser. So you'll have taken about 2,400 sessions during this 1 year duration. 2,400 sessions, that means that per session you're just paying about 12.96 rupees, which is less than correct. Yes. So yeah, people, check out the link that is given in the description, and yes, make your life yours. That's all I can say. Moving on to the 7th question, people. Another easy question. I'm pretty sure you'll be able to do this. It's an exemplar question, so I'm pretty sure you'd have probably seen this if you've gone through your textbook at least once. And I'm pretty sure you should have, at least by now, you should have gone through it at least twice or thrice. So that's not an excuse. Here's the first one. Here's the 7th one. In an electrical circuit, two resistors 2 and 4 ohms respectively are connected in series to a 6-volt battery. The heat dissipated by the 4 ohm resistor in 5 seconds will be what? 5 joules, 10 joules, 20 joules, or 30 joules. Another easy question is, first of all, if they're connected in series, what will be the equivalent resistance? So R equivalent would be 6 ohms, because it'll be 4 plus 6. First of all, find out the current is. Current is equal to V by R. Voltage is 6. Current is 6. Resistance is 6. So it will be 1 ampere. Now use the formula. H is equal to I square RT. I is 1 square into R is 4 into time taken is 5 seconds. So 5 fours are 20. So 20 joules would be the answer for this question. That's it. That's it, people. Last and the final question. This is by far the longest question that we are ever going to do. This was asked in 2011 question. Another very important question. The question is, it's something that you have to read very carefully before you answer. The question is this. Two devices of rating 44 watts and 220 volts and 11 watts and 220 volts are connected in series. The combination is connected across a 440 volts main. The fuse of which of the two devices is likely to be burned when the switch is on? That is the question. Now I'm going to first of all try out this question, but I want you guys to do it with me. So give your 100%, give your best shot at this question. Super important. So let's try and do this. All right. So here's the thing, guys. The current rating and the power rating and the voltage of the first one is also given, and the second one is also given. So what I'm going to do is I'm going to use the formula, that is power is equal to V square by R wala formula, because power is equal to V into I. So in place of I, I'm going to substitute V by R, and I'll get as V square by R. So I'm going to find out what is R over here. So what is R for the first one? R1 is equal to 220 the whole square divided by R is what? Power is what? Power is nothing but 44. So if you calculate this, you'll get something as 1100 ohms. Alright, for the first one. Now for P2, this I'll take it as P1. Okay, we'll take it as P2. P2 is equal to V square by R2. So R2 is equal to 220 the whole square divided by 11. So if you again substitute this, you'll get it as 4400 ohms. Now, this is the resistance. This is the resistance, all right? So, the first one and the second one, you found the resistance first. Now, they're connected in series. So, find out what would be the equivalent resistance. Then, R equivalent would be 1100 plus 4400, which makes it 5500 ohms. Simple. Now that is out of the picture, you have found the equivalent resistance. Now, you're supposed to find out which of these would produce, or which of this is more likely to get burned, right? So let's find that out. So for the first one, that is H1, we'll take it as what? I square RT. So yeah, we'll do one thing. We'll find out the equivalent current also. We'll find out the equivalent current, all right? We'll find out the equivalent. So we'll find out the current passing through the conductor through this entire circuit. So current is what? I is equal to V by R. So it's 440 divided by 5500. So if you simplify this, you'll get as 0.08 amperes. All right. So if you calculate this, you'll get it as 440 divided by 5500. You'll get it as 0.08 amperes. All right. So simplify this, you'll get the answer as 0.08 amperes. Now that you find the current, now put in the equation, that is H is equal to I square RT. Wow. Yeah, this is a long one now. All right. So 0.08, the whole square into resistance is for the first one is 1100. Time taken will take it as 1 second. All right. So if you simplify this, you'll get a 7 point something, 7.50, 7.04 or something like that you'll get, alright? 7.04 joules is what you get. For second one, that is H2 will be what again? I square RT again. So I square R this time is 4400 into T is 1 second. So if you simplify this, you'll get it as 28.16 joules. All right, so this is what you're getting, right? So again, I'm not doing the calculation because you guys are good enough to do that. Simple multiplication, but you'll get the answer as 7.04 and 28.16. So it's very clear that H2 is definitely greater than H1. So you can say with confidence that the second one, that is the device which has 11 watt and 220 volts, would be the one that would get fused or is more likely to get burnt before the first one. So that's the answer, guys. That's all. That is the answer for this question. And that is the end of all the questions that we're supposed to do over here. But yes, also have a homework question for you guys. This is the homework question for today. Compute the heat generated while transferring 20,000 coulombs of charge in 5 hours through a potential difference of 220 volts. Let me know what is the answer, guys. I'll see you guys in the next one. Thanks a lot for joining. And do not forget to like, share, and subscribe. Thanks a lot. I really appreciate all the support and love that you guys are giving me. And I'm really sorry that I've not been able to reply to you many of your emails. I've been out for a couple of days now. So once I'm back, for sure I'll be replying to your emails as well. Thank you for your patience, guys. I love you guys all. Take care and all the best for your exams. Good night, guys.